So usually on these, you tend to talk about the new things that you're doing, the new things you're working on that you don't really understand. But I didn't really have anything like that when the call for proposals was. So I thought I'd talk about the oldest thing that I've worked on that I still don't really understand, and that's the KCC, which I first worked on in 2015. It's 9 years ago. And that's when I first worked on Samba. And what does it do? Well, it finds a graph, a replication graph for Active Directory domain controllers. It was invented in the 90s. It kind of shows. And we made our version in 2015. Well, we've finished our version in 2015. Anyway, so what the kind of thing it needs to do? Imagine if you've got two DCs, they can replicate to each other, and that's simple. And then if you've got three, it's kind of simple. Each one can talk to the other one. If you've got four, it still works, and yet more and more and more, and then you kind of get to the point where you start thinking it's going to be too many connections. And when you get to like 100 DCs, they probably spend a lot of their time just dealing with replication requests, and the network is slightly flooded with sort of empty messages because they're just asking each other what's going on, and there's nothing actually new happening. So rather than going fully connected like this, the other way to do it would go minimally connected like this kind of thing, where any change on any DC will get to the other ones eventually. The only problem is if one of those links or one of those DCs fails, then the whole thing stops. Like you won't be able to get from DC3 to DC5, and also it could be slow. Then one way is to put shortcuts in, or another way is to make a doubly linked list. And this is actually what the KCC does for computers on a site, which I'll get into what a site is. But now imagine if you had your DCs in two different cities, then the doubly linked list, like if you're trying to get the message from server DC1 to server DC3, you don't want it to go through Wellington. You want it to go the other way. And especially if you're designing this in time for Windows 2000. So it kind of looks more like this, that your graph really should. So what the KCC does in this case is it makes the for each site, it makes a fully connected graph, and then it actually makes a tree between them, between the sites. And that's really all it does. So the inter-site graph is a tree. So if you've got 5 offices in 5 cities, it'll draw a tree like this, in a deterministic way, but different every time. And actually it'll draw 5 trees, because it does one for each partition. And so in Active Directory, you've got different partitions. It's like the whole thing happens independently 5 times or 3 times, depending on your on some things. And the order and which site links to which other site depends on the GUID order. So I can't remember the details, but say you start with the lowest numbered GUID, just sorting them as if they were strings, or maybe sorting them as NDR blobs. Now, so if you compare these two trees, one of them is better than the other if you actually are aware of the geography. Like ping time from here to Europe is, I'm in Wellington. The ping time from here to Europe is about 300 or 400 milliseconds. And then between two cities in Europe, it's probably much shorter, I'd imagine. And probably especially with Windows 2000, you don't want to be paying for international traffic, so you want the tree on the right, not the one on the left, or you want some other tree that also, like maybe you want Lima between server and Europe. Anyway, the way you can do that kind of thing is you make it a site link object which puts links together. So now Nont can only see Inverness, and Inverness can see server and Nont, but as separate things, whereas the server Wellington and Lima can kind of form their own tree out between themselves, and that so that means you can persuade the KCC to do what you want when it's not doing what you want, which is actually some of the time it's doing the wrong thing. And you can also put a cost on a site link, where so you have a so I mean it's from the time when you might have had, so these links are way above the physical layer, right? There's just they all know each other's addresses, DNS addresses, I guess, and they just are deciding which ones to talk to. But in the old days, you might have had, a T1 line somewhere in ISDN or something, and in another place, and you might not want it to, or a satellite link, you might want it to not use that route. I mean, this is when they were making it when, like, I don't know, Windows NT, did that ever? They must have had a TCP stack. But I think Microsoft thought that, TCP/IP was one of those fads that was going to pass, and that it was kind of like direct leased lines or something was what people were using. Anyway, you can put an extra link on a site link and give it a cost such that it won't ever be used. But the easier thing to do is to not put the link on, and then it won't be used. So anyway, so there's this cost thing you can put on a link, but it's better just to ignore it. Everyone ignores it, and they just put the links on that they actually want to work. So within each site, so see this server site, if you remember back there, there were 3 DCs in there. And there's and inside the site they're linked in a ring. If you put more DCs on, it gets to the point where it gets to be more than 3 hops between say DC3 and DC6. And at that point it starts putting in random cross links, and they truly are random. It's just like picks a random source point and a random endpoint and puts in a link, and then so it just sort of makes a messy spider web between the DCs within the site, and that's basically all it does. This is the whole thing. As between sites, it makes a tree. within the tree, it makes a ring. It's a linked ring. I'm just going to see if I can find the chat, because someone said pretty. Thank you. Okay, so that intersite trees are based on Dykes' algorithm and Kruskall's algorithm. Intrasite, yeah, I've said these things. And at the edge of this, at each site, it chooses a bridgehead to be the one that talks to the other ones. Now, it doesn't always do this successfully in our case, but it's meant to. And so that there's, like, one of the DCs has just said, you're going to be the one who talks to the outside world. And the rest of them are just kind of talking between themselves. And then some are told that they're going to be the ones who are going to work out this tree for the outside world. So the thing with the KCC is wherever you are, you can generate it. Whichever DC you are, you can generate it from what you know in the database, and it should work out the same. And that's a useful property. Now, because if your network is a bit broken, they can work itself out, and they start talking to each other, unless you have put unless they've got different site GUIDs and different DC GUIDs, in which case they don't even know about each other. So okay. So that's kind of like how the theory goes and how it's written up. Now, what we have, we used to have a KCC that had fully connected graphs like the ones at the beginning. And then in 2011, someone called Dave Kraft started writing one in Python. Now, the idea was that it would run in Python as a subprocess of the the server process that was doing this KCC. Whereas the old one, I think it ran in the server process itself. So running as a subprocess is quite a nice idea, because it can read from the database and change things and then write them back. And then it can leak as much as it likes. It can be slow as Python. It doesn't hold anything up. So Dave Kraft did a really quite good job, but it wasn't a small enough task for him to finish before he went and did other things. I think he was working with Tridge, but it still wasn't a small enough task. And then Garming and me, we had a go at it, and we had budgeted a couple of weeks to finish it, and it took like 8 months to not really finish it. So the specification is a bit hard to read, and it's not really easy to test. So the way the KCC works is that it has these things called NT-DS connections, which are really only used. They exist in the database, but they're only used by the KCC to do its calculations. And then at the end of it, it has to put on a reps2 and a reps from link. And what a reps from link is, you have a list of them, and you go through the list, and all of the ones that are on there. Every now and then, periodically, you go and ask them, have you got anything new? And they either give it to you or not. And whereas reps2 is if you got something that you think the others might like to know, you go, hey, why don't you ask me what I've got? I'll tell you the news. So the reps2 is kind of like a push, but it's a push where it's just like saying, ask me for the gossip. And the only thing that really matters from the KCC is that it makes good reps2 and reps from, making everything connected to each other efficiently but not too connected. Now, if we didn't do it the same way as Windows, if people ever used mixed domains, so they don't, but if they did, like if the Windows machine, in this example, if the non intersite topology generator, if it decided that the way to the outside world was through Wellington, and if Wellington Samba servers decided the other way, then when they were trying to, then they wouldn't replicate out to the rest of the domain, and they would just kind of wander off on their own. So we need to get things more or less the same as Windows, and that at least in the intersite. And the intrasite, which remember is a doubly linked ring with extra links, it'd be pretty hard to get it badly wrong, even if we got the ring different, because there would still be a root. So the trouble with our KCC, well, the trouble with the KCC protocol is it's badly documented. It's like Volker was talking about a 500-page document for the NFS, and this isn't that much, but it almost should be. It's like they tried to squeeze it into 50 pages or something, and then they wrote 50 pages of pseudocode, and then they left things out that you don't quite know what they left out. It's hard to ask the right question because we just don't know. And then there's a whole lot of things that just shouldn't be there anymore. And to test it, like to see how it works on a domain with 50 DCs with sites all over the world, you really want to try things out. But the people who have those sites, they're not really so keen on us testing it on their sites, on their domains, and it also is kind of meant to settle down after a few runs. It's sort of like builds on its previous work a little bit, and so you can't just do it once. It's hard to write a self-test that checks that it works properly. But we tried, and it was me and Gumming and Dave Craft all kind of not really knowing what any of these things were. Well, Dave Craft, he seemed to know, but I didn't. And then there were Python binding bugs that just made it much harder. Like this is in the code right now. This warning about a reference counting bug that somehow we managed to get around by tricking Python into getting its reference counting wrong in the other direction that we got it wrong. And but so that like this code, it should be sort of just, you should be able to say self.ndr blob equals. But it does all this complicated stuff with we'll use modifying self.dict, and so the Samba KCC that we've got is full of kind of like weird workarounds about things that I'm pretty sure we've fixed. Maybe we'd fixed by 2015 when we were working on it, but I think we've fixed now because we don't have this kind of Python binding bug anymore. So we could if we could sort that out, it would we'd lose hundreds of lines of hard to read code. But because it's hard to read code that actually does some tricky things, it's hard to fix, especially because no one really cares. Now Samba, the KCC is supposed to check that the links that it currently have point to an existing DC or something, they can work. And we don't do that. We actually have the option, but I don't know why. For some reason, we made it an option that you need to that we didn't turn on. So I've just discovered that in the last few days. And there's things like, so when Windows did it, you could use an IP transport, or you could have your DCs sending email to each other as a way of getting their replication messages or their KCC messages around. And like we just say we're not going to do the email one, which is a good idea. But there's a lot of other things that we do that, and we do just to be compatible with Windows because we're trying to follow the spec. And then we find that we don't use those anywhere, and we probably don't want to use them anywhere. And Windows probably doesn't use them anywhere because they're old and useless. So, and because at this level, we're not talking about client things, that users use. It's the interoperability. It's just like whether you're making a link to the other DC, or you're letting them know about each other. It doesn't really matter if we follow all of the weird little things like this two-way sync and stuff like that. There's a huge long list of this kind of flags that we set and fiddle with and stuff like that. But when you look at where they're used, if they're anything, they're just it's like a local variable for the KCC, and nothing else in the code refers to them. So we should either drop them or just make them a local variable. Anyway, maybe not all of those. I'm sure someone will find a counter example. And so those pictures that I was showing before, though I didn't actually make them with the Samba KCC, but it can do that. It's using it can write a dot file showing you what it's done, and which you can now do with Samba tool visualize. And it's got a whole lot of routines that follow its graph to make sure it hasn't made a loop in the intersite graph, which actually wouldn't be a tragedy if it did. But we were trying to find out Windows, and to make sure it has done the doubly linked loops and all that kind of stuff. So it's kind of got a whole lot of graph theoretical testing things. It's like, because at the time it seemed like it was the right place to do it. And it prints out a lot of debugging stuff that you can either turn all on or all off. I think Metza has complained about that before. And in lots of different colors, because I like printing in color in those days. I still do. And it can load in an ELDA file. So like a lot of it is about loading in an ELDA file so you can test it. So this thing that, as you saw before, what it's actually doing is drawing a simple graph. It's like, I don't know, forgotten how many thousands of lines, but it's lots and lots that shouldn't be there. And it ends up kind of leaking a few reps2s and reps froms that shouldn't really be there. And that's actually a good thing. It gives it resilience. And, if it didn't do that, we'd probably have much more troubles than we do. So yeah, it could be smaller without losing anything. It could be much smaller and better, I think. We could, because we are following what Windows does, without good reason. Like there's one thing. There's this, every link is given a schedule, and the schedule is like, it's got 15-minute resolution over the week. So you can say that you don't use this link on Tuesday afternoons because, I don't know, the pigeons need their afternoon nap or something like that, right? So we do a whole lot of stuff to calculate this, get it right, and get it in exactly the format that Windows does, and then we just don't use it because that would actually complicate our real code. And Windows doesn't use it because, well, I mean, if you put it in, it would, but nobody does. The same with the site link costs. I don't know if anyone uses them. It's just like a configuration thing that seemed good at the time, and it isn't. Now, if you do use these tools to make a picture of your network, quite often you'll find that your NTDS connection graph, which is the ones that Samba KCC is thinking in, and only it cares about really, you'll find that you've got sites that are hanging off in the void with no one else talking to them, and you think, oh dear, but nothing has stopped working. All the replication is working well, because when you look at the reps from and reps to graphs, everything is there. So we have a KCC that is thinking it's doing this. It's kind of come to the conclusion this is what we need to do, but what it actually does is this. I don't know how that works, but this is more what you want. Like you can see on there, there's things that don't meet the specification. There's about between server 1 and getting in. There's like 5 links, and there's a server 3 has got like a self-reference and stuff like that. But it works, and the whole thing seems to not cause many complaints. Now, it might be that I don't know that I'm able to filter out when I can. Maybe I just don't see the complaints. I don't look in the Samba list at every message, but it seems like it works for almost everyone, and they just have trouble with other stuff. And actually, that's all I've got. It was quite quick then. So, does anyone have any questions?
So Douglas, is the plan now to remove that 50 or even 90% of the code as you suggested?
No, not really, because the plan is to do things that are more urgent. I would like to, but I don't think anyone needs it. Oh, where that window's gone. Okay. My plan, what I thought of when I proposed this talk, is I thought if someone else understands it, not me, that'd be good. But and then I still don't understand it. Like I don't understand why we have such a complicated system. I know how we got there, but I think we don't need to. But to undo it it's not easy, and not urgent if it's working.
Yeah, and it works as it should. So yeah.
Yeah. close enough to how it should.
Is it so? How did you generate the two different topology graphs here? The one that we're looking at here currently, like the reps from reps to, and then the other one where you say what the domain controller thinks it is doing. Is that some way to specify that with the Samba tool commands, or?
Yeah, or with the Samba tool visualize. Oh, hang on. I think this one here. So Samba tool visualize reps dash dash dot. So this is not. It won't be exactly like that, but it is kind of that. It doesn't have the coloring of the. This has got site coloring, so that I should make it do site coloring because I quite liked it in doing this.
Yeah. But what I was referring to was the two different graphs that you generate. So here you have one command, right? But you're showing two different graphs.
Yeah. So that's if you change the
reps to reps from, and the other one the NTDS settings.
Yeah. Like if you go dash help, it'll give you. I think you write NTDS.
Okay. So that's just an option to.
Yeah, and then
one or the other one.
Yeah.
Okay, interesting.
You can run
because the first one looks really scary. Yeah, that one.
Yeah.
Okay.
Yeah. So this isn't a real domain, but it is following some I've seen.